Thank you everyone for joining this session. I know that's the last day of the conference, almost the last presentation of the conference. So I know that all you're tired, party hard last night, so I really appreciate your time here. So we are going to be discussing some hypothetical architecture, actually based in some of the offers that we have in the cloud. But this is going to be a hypothetical architecture that we are going to trying to get a resilience of 4 nines. My name is Regilo. I'm the director of a cloud delivery in InterSystems, and we have Eduard.
Also with InterSystems, senior cloud architect.
He's the guy that I try to get the most, and he said that no. I always try, like, can I have another extra 9 there? And he said, no, it doesn't work like this. I needed to have more things to work there, and that actually have more work to be done. So let's start with the agenda. So that doesn't work. Okay, yeah. So we are going to discuss that it's not just about resiliency. There are a few other things that you need to take into consideration. There are factors that you need to take if you are going to implement such architecture. We are going to discuss what resilience is, and then we are going to really dig into what you needed to do to get the resiliency that you were expecting here. So we are going to separate these in a core platform, the supporting services, the R backup, and the validation. But the meat of the discussion is going to be the 3 topics: the core platform, support services, and the R. And feel free to interrupt at any time. It's like I want this to be more a discussion than really a presentation. So resiliency is not everything. So if you're familiar with a cloud, AWS had their web architecture framework, Azure, they have their best practices, Google Cloud has that as well. And I'm stealing here the idea from AWS that actually has 6 pillars on their web architecture framework. That is basically security, so that's something that we cannot negotiate. We have cost. That is going to impact when we talk about resiliency. We have performance, we have operational excellence, and we have resiliency. So operational excellence kind of work together with resiliency. If you monitor your environment, if you know what is going on there, you're going to have a better resiliency. Cost is our enemy at this point. Every time that you're trying to increase resiliency, cost is going to increase as well, and we don't like cost to increase. So pay attention to that. So what's resiliency? Resiliency is not you preventing something to happen. It's planning that something is going to happen and recovering from that. So you needed to plan an architecture that anything that happened is going to be able to survive or to restart, to restore at a point in time that your service is going to be working properly. Sounds okay so far? No mystery. Excellent. So the first thing that I asked Eduard is like, Eduard, you know what? It's really important to understand how we are going to calculate our resiliency. So if I not can get a 9 for free, so tell me what I needed to do to get my extra 9. So there are 2 ways to calculate resiliency: serial and parallel. The first one is very simple. You get what the SLA of the services that you have in the cloud, multiply, and then you have the SLA from that service. Unfortunately, this is not fun, because even though that you have 4 nines there and 2 nines, 3 nines, well, on average should be 3 nines, but no, it's going to be 98.9. So we are not, every time that we have a serialization, you're going to decrease the SLA of your product, your offer, your service. Solution, thank you. But I really like the parallelization. The parallelization is nice, because now I don't take the SLA from the service. What I get is the probability of a failure, and get that probability -1 and get how much that's going to be. I calculate the probability of failure, and then I get my SLA. And that increases my SLA. So that is much nicer. So, sorry, this is wrong. The one on the bottom of this card is just the one on the top. But that is nice. So, Edward, I want more of this one here. Okay? Just to be very clear. So, everybody's okay with that. Everybody's okay with. Thank you. Discussion time. Yeah, Edward is already finished everything. Can you go back to that, Edward? So everybody's okay on how to calculate the SLA. So if I have a service that has, let me see if it's going to be thank you again. Can you move another one? So if I have a service that is going to be 3 nines, and I'm going to use just that service, great. But unfortunately, it's not just one service that we are going to be working. So let's take an example of this very simple architecture. I have an Iris, and if you have an EC2 in AWS, they are going to give you 99.95%, if I recall well. So that doesn't make the cut. I told you, Edward, I want to have 4 nines. And so far, that is not going to cut. So I'm going to make that in parallel to increase my probability. The SLA for EC2 in a region for AWS is 3 nines, or 4 nines. So that's already, I like that. That's what I want. I needed to connect that EC2 to my environment or to my customers or to whatever that needs to be. And then I'm going to use a direct connect. I could use the internet as well, as you can see there, but internet doesn't give me an SLA. So I needed to use something that is going to give me an SLA. Direct connect is my option. They give me 3 nines. I don't like that, so our friend parallelization, I'm going to get 2 direct connects. Now I have, I think, 6 nines there. I like 6 nines. And of course that I needed to have a front end for doing my APIs, and I have the back end that's going to be my, my database, and we have the arbiter there. All of them are going to be in different availability zones because that's what I get the SLA from AWS. But Edward, I have a problem. Our mirror only work in one subnet, and I have 2 subnets here. What I can do? Yeah, that's the face that you should make to me. It's like, what the heck you were talking about? So how the VIP is going to work on this scenario here?
Since Iris in this scenario is not a network admin, and we cannot just have one subnet with IP, virtual IP. Even if we could do that, right, we still cannot move it in a cloud by using Linux networking tools. So what we can do is instead look at the virtual IP as a resource in AWS, which it is. It's elastic IP address and the route to it. And what we can do is we can change the route to a virtual IP every time we do a failover automatically, because Iris provides a variety of callbacks like zstart, zstop, zauthenticate. One of them is zmirror, which is called every time a mirror event happens, and failover is certainly a mirror event. We catch that and implement our logic to point the routes to a new primary.
Excellent. So now I solved my problem. I have exactly the 4 nines that I want. Oh, wait a second. That doesn't really go exactly what I was expecting. I calculate everything there, and it's giving me 3 nines, almost 4 nines. So, okay, that really didn't do the job that I asked you to do. I want 4. I don't want 3. And even though that is almost there, I want more. And I have another problem. Unfortunately, and you're going to be all witnesses of this, is not just Iris that I needed to have. I needed to have other services from AWS. I needed to have an EFS. I needed to have an S3 bucket. I needed to communicate with others. I needed to make an authentication. That is another problem that I have. I cannot synchronize users there. So how we can synchronize users as well? Because that's another thing that I have to solve.
Why don't we add another service, which would be AWS Cognito, for example, or some other external service, but if you're hosting in AWS, you'll probably want Cognito for the SLA.
Okay. And if we have I have to be far from you. So if we have some certificates, for example, so I cannot synchronize certifications, the certificates anyway, the CAs. So what we can use there to make sure that I can have access for both CAs and both mirrors.
So we host Iris on EBS vault. And while they can be attached to several instances at once, that is usually not the recommended approach. There are a lot of limitations. So what we can do is that we can create an EFS, which is a managed file storage, which is entirely separate from the EC2 instances themselves, but can be mounted. And even if the EC2 instance goes down, the certificates and actually all the data on your EFS would still be available, and you can mount it simultaneously at a way larger number of hosts than EBS.
Excellent. So I'm adding more and more services here. So I have now Cognito, I have EFS, I have a family transfer because some customers want to be transferring large files, and that's the easiest way that they can do. I can have my certificate manager. I can have my Route 53 that surprisingly they guarantee 100%. So I like that one. But all the other ones there are give me a little bit more challenging. And if I serialize all of these here, it's going to decrease even further my deployment. So I'm going backwards, Edward. Instead of getting the 4 nines now, I'm getting 995, not even 3 nines now. So I think I'm having some challenges with this architecture that is not going to make the cut. And everybody wants extra nines, not decrease the nines. So the only other thing that we can do is, can you move to the other one?
Is to another region.
Yeah, very good. But can you press the button there? Excellent. So let's parallelize the architecture so we can have not just one region, and then we have 2 regions with the same services to adjust to that. And if now we calculate that parallel, it's really tiny to see there. But now I have almost 5 nines. I have 99998. The problem with that is that it becomes expensive. So everything that now I'm doing in one region, I have to pass to the other one. How we are going to do that is doing VPC peering, because at least VPC peering is cheaper. You're going to have to expand with a communication between regions, but it's not the most expensive thing. But I have EC2s, I have storage, I have all the services. I have some challenges with, for example, with my authentication. Today, AWS is supporting just one region, so I have to create a script to move the data to another region, even though that we are working with AWS, and that sounds that very soon they are going to be supporting active passive for the cognito, and a little bit further is going to be active. So it's less one thing that I need to worry about, and they increase in SLA to 4 nines. That is more to my taste. So that is going to get better and better on this. But there are few challenges that you're going to have on network, because now you needed to be considering how you're going to transfer all the traffic that you're going from one region to the second region fairly seamless, so you don't have a disruption of your services. The other thing that you needed to pay attention is that there are, especially, I imagine that everybody's in the healthcare here. Yeah, I imagine that. No? Who is not in healthcare? Oh, okay, very good. So I imagine that, I don't know if you have any IoT in the business that you have. No? In the healthcare, we are going to have a lot of medical devices that don't renegotiate connections. And that is always a challenge. Because if you fail over to another availability zone, or even worse, if you fail over to a different region, then someone is going to have to manually go there and say, oh, here, we need to reconnect this medical device, which is a problem. There are some solutions for you in one region. So if your device support ECMP, that's a protocol that your firewall just feel that, oh, it's just one connection, that can work pretty well. But it's not going to work for 2 regions. So depending on what you're trying to achieve, you needed to take in consideration not just the architecture, but you needed to consider also the upstream and downstream systems that you're going to be connecting to that. So far, so good? No questions? Everybody agree with me? Everybody's going to implement this architecture tomorrow? Very good. So one of the things that is not here, there are a few things that is not in this, explicitly in this architecture, that is important to notice. Resiliency is not just SLAs. There are much more than that. It's how you do operations. As I mentioned, operation is going to be working hand to hand on resiliency. The way that we recommend to implement anything in the cloud, doesn't matter what cloud is using code. So your infrastructure should be all code. In the case of AWS, let's build cloud formations. Takes us about 15 minutes to deploy all this architecture in AWS. More or less the same in Azure, using Bicep with ARM template. So you can recover pretty fast if you need that. The other thing that would be interesting to consider, I had another point on that, and now I'm looking at the graphic and don't remember what it is. Well, I'm going to make it up something now. So just because I said that I had 2 things. Well, monitoring is extremely important. If you can see that you're going to get a problem and be proactive on that, of course, it's better than start recovering from disaster or recovering from a disruption. So having your security, your monitoring, your performance all squared out is always important. Edward, what I'm missing here? Nothing? Very good.
This looks very comprehensive.
Yeah, so there is one more thing here, because it's nice to have the architecture there, but more important is having the data. And you have to have the data in the 2 regions if you're going to implement the 2 regions. With the Iris, it's easy. We can use our mirroring technology. We can do for the same region, 2 availability zones, you can do sync. For the other region, you can do async, and you can get a sync again when you're in the secondary region. But my certificates, for example, in EFS, doesn't use mirror. So what we can do to get the certificates or files that are on the system to the other region.
Cross-region S3 replication.
You are very direct. Yeah, I thought that you were going to be like, oh, let us discuss more about this. But yeah, let's just do replication on this. Yeah, so that's one of the things that is extremely important, is that if you have any type of data, is having replication for any services that you have. Can be authentication, can be authorization, can be certificates, can be any backup that you have. So actually, can we jump to another one? I think that is backups. So I was really impressed. I was hoping yesterday that nobody would come to the booth to discuss about backups and demos and drink. And by my surprise, we had a really good amount of people. Actually, the night before, we had a lot of people that came to the booth to discuss the partnership that we did with AWS to improve the snapshot backups that we are having with them. And this morning, we had Mark Bolinsky also discussing about the new online backup, and a lot of you were there as well. So I'm excited to see that people are still paying attention to that. I know that is not the sexiest topic. Is not AI. We joke a little bit. We should have put snapshot backups with AI, and that definitely would come double of the people and the booth. But is still a very important thing. It's something that everybody just leave on the side, just going to remember when they have a problem, and that's too late when you get the experience. But anyway, going back to the backup, we recommend that you have a full backup, put that in S3 buckets. S3 buckets going to have 13 nines of resiliency. Is not uptime, is not availability, is resiliency. So it's almost certain that you're not going to lose your data. And if you replicate these to another region, then you have 13 nines of a resilience one and another one. Multiply that. It's going to take less than 13, but it's going to be enough to make you happy and not having to recover from a long disaster. And yep, I think next one. And then we needed to discuss about validating this. Just having an architecture that can recover, and hopefully most of your architecture is going to be recovering automatically, but we also needed to have the people working on the environment very familiar with what is the standard procedure to return to a position that you feel comfortable. So you needed to be testing or doing game days. That's what we have. We just had a game day last week that was create a scenario. And I think that someone here in the room is very familiar with game days as well. And create scenarios. Let the team figure it out if they are ready or not. Trying to break things, make a chaos engineering, and making sure that your team is prepared that when something goes wrong, you are going to be prepared for recovering from that. So it's not just about our infrastructure, about the code, it's about people as well. And I think that's the part that we forget the most. Any question? I thought that we were going to be discussing. Fernando didn't say a word there.
I have few comments.
Awesome.
First of all, great presentation. Thank you.
Thank you.
You did a little bit of mixture between high availability and disaster recovery.
Yes.
So the first thing that you should have said is that high availability is more about planned downtime, and disaster recovery is about unplanned downtime, which are totally different.
Mm-hmm.
Now, we are working in Azure, but
Mm-hmm.
I assume that things that you said about
Similar.
AWS are similar.
Yeah.
Now, it's very nice to have 39s on the backup storage
Mhm.
in AWS or even in other, but it depends on your database size. So if someone is having, so backup is not answering the high availability question,
Mhm.
because if someone has a 20 terabyte database, it doesn't matter if you use Iris internal hot backup, which is going to be a parallel very soon,
Mhm.
because restoring takes like double time of the backup itself.
Mhm.
So if we are talking about
Think
5
hours.
of,
Yep. Mhm.
you know, doing the backup, or even if it's snapshot,
Mhm.
it will take hours to recover.
Yep.
So it's not about recovering from high availability or even disaster recovery. It's a different topic of having your data available and you don't lose the data.
Mhm.
If you have some incident of someone attack your system and try to to wipe your database.
Yep.
That's the problem.
Yep. I completely agree with you.
And I have another question. The slide with all those colored things, all the orange one was Iris instances?
So it's not just Iris. For example, you have Apache servers there because they have
In
some.
the middle it's Iris?
So
Or it's different?
so here, for example, you have mirrors. Oh, actually, I left the mirrors here, but these would be CSP gateways.
Okay.
And of course, they needed to be also in parallel, so you can have availability on that.
And again, if people want to get a better resilience using Miro, then you have to know two things. It depends on the system. So if the system is super busy, you have to distinguish between async and async.
Mm-hmm.
On sync, you don't have RPO. You have a very small RTO, which is depending on the complexity of the production, of the interoperability.
Mm-hmm.
This is running, because usually it takes between 10 to 15 seconds at best to put up the interoperability on the backup when there is a switch.
Yep.
On the other end, on async, again, it depends on the you have RTO and RPO, and depends on how busy the system is. So this slide is DR, I understand.
This is not just DR. Again, we are talking about resiliency, but yes, you're correct. There is some availability here as well. And when you have in different regions, that will be async. And basically, you can get, again, sync in the other region.
Usually DR is another thing that is distinguished between HA and DR is that the HA is automatic.
Mm-hmm.
DR, someone needs to press the button. And usually the main issue is DNS.
Yeah.
I don't know about AWS, but the thing that you said is very similar to Azure Site Recovery
Mm-hmm.
in Azure.
It's a little bit different from the Azure site recovery, because that is just replicating the storage and not having the compute on top of that. And then when something happened with a ESR, then you bring compute as well, and then you have that working. So it's a little bit different from that. Actually, AWS has something similar to as well as AWS disaster recovery, but it's not going to be on this. That could be an alternative for an architecture as well.
Can you say something about InterSystem licensing regarding those scenarios?
I'm not sure anybody knows about license. I don't know anything about license.
Is there going to be any change? For example, in high availability, you pay licenses for every sync or async members that you have, regardless if you divide them to availability sets or to zones or to regions.
Mm-hmm.
In DR, the current situation, as I know it, is that InterSystem is not charging for servers in DR, regardless if they are hot or cold. But I'm asking if there is going to be any change in this policy.
I'm not sure. I'm not in the license. I'm not in the sales part of the business, so I cannot say about that. What I can say is in the cloud services that we take care is all consumption based, so we don't really care about the license. So it's basically, oh, let's say that you have in Health Connect Cloud is how many messages that you're going to process, is not how many cores that is going to be there.
We are using Iris on the virtual machines, not as a SaaS. So
I see.
I understand.
Yeah. Very good. Great comments. Thank you. Yeah.
We've talked about doing something similar, about manufacturing a DR event or something, and then sort of forcing people to like actually physically go press the button, right?
Yeah, well, that is very easy to do. What I do with my team is like we have several in the cloud. We can make as many deployments that we want, and then someone can go there and just pull one of the plugs. And well, what I do is like customer just calls saying that it has a problem. They can access the environment anymore. Go figure it out.
And you can add an SCP to simulate failures, like deny on a specific service on a SCP level. So on account level, there is no way to avoid that, for example.
What's for the journal latency on your region-to-region DR? How, like, what type of speeds are we going to need for that cross-region?
So that's something that you're going to have to consider how much data that you can lose. Theoretically, you can put async members anywhere in the world, but that means that as long the latency is going to be, as more chance that you're going to lose data. And
so on your diagram here, like, or no, if you go to the next, is this, yeah, this is the multi-region.
mm-hmm.
So you're completely replicating everything from one region to another.
Mm-hmm.
What we've found that we can do, because cost, which you
Yep.
said is always our enemy, right?
Mm-hmm.
Well, on a DR, you're failing over anyhow, so you're going to have to hydrate, you're going to have to do some other things. So what we end up doing is on our DR side, we run super small,
Mm-hmm.
and we run just big enough to get the journal replay,
Yep.
because we're not running any app load there.
Mm-hmm.
It's literally to have a database ready to go, so that way we don't have to get a backup.
Exactly. And one of the things that we didn't mention here is that it's very interesting to use the ASGs, autoscale groups, exactly because of this. You can run very small in the secondary one, and then if something, you needed to fail over for that one, takes about a minute or two, and then you can have a completely different size.
Where you're failing over to the region, you're waiting for DNS and other things as well.
Yep.
So the way we looked at it is we have time to bake the other stuff and get everything else hydrated.
So one of the things that we are using here that prevent a little bit the problem with the DNS is using external ENIs for the VIP. What
yeah.
is?
Elastic.
So yeah, you just use the IP address, and then you can point that IP address to the location that you want.
Okay, got it. That makes sense.
Any other questions? Sam, I see you almost asking a question. No? Okay. So thank you for your time. I think that I give you 10 minutes back so you can enjoy. And we are going to have a discussion about the strategy on source control here as well in a little bit. That's another thing that is very interesting. Ben is going to be presenting that. And of course, we have ice cream a little bit later.
Yeah.
Thank you.